Hello, fellow Flutter friends. Today, I'm bringing you about 9 great tips in Flutter to improve your developer experience and to just build better apps. My goal here is to provide tips that are plugin agnostic, meaning we're not going to be really installing any packages and being like, here's a great tip for Riverpod, here's a great tip for Block. No, we're just working with core, basic, material app Flutter. And yeah, some of these are pretty basic, but super helpful, and I use these all the time. And some are a little more advanced and, only need to be used in certain use cases. Look at the chapter list below if, you are bored by the one we're on right now, and skip to it. I don't mind. But I hope this is really helpful. And I'll be putting up this code in the link below on GitHub to, allow you to kind of play around with it in case you want to try something a little bit different. Okay, so let's get into it. Number 1 is actually, I have up on the screen here, FVM, Flutter Version Manager. So this is something similar if you use Python. It's kind of like using something like PyEnv to have different versions of Python. Node has something called NVM. This is really useful, especially if you're maintaining a project, multiple projects, and you're not really ready to upgrade your global Flutter to different versions. You can essentially have a project by project Flutter version. And I'm going to show this because I the other day was like, I want to start playing around with the newest version, which at the time of recording was Flutter 3.22. And in that, I want to use FVM because I don't want to actually update it globally. So to get this going, we can go to fvm.app and go to the documentation, installation. And the recommended way on Mac OS is to either use Homebrew or just install with an SH right here. You can do it through a pub, but it doesn't recommend doing it this way anymore since the newest version. And there's Windows and Linux instructions here too. So I've already done this part, but now I want to start a new project. And because I want to just have the project already set up with the latest version of Flutter, I don't want to use my global Flutter to initialize the project. So what we actually do here is, first of all, so it's installed, and I can just go FVM to make sure it's installed. Cool. And what we're going to do is we're going to go FVM install and then pick a version. I'm going to do 3.22.0. Now I already have this one installed, but you'll see this will actually download, the version of that to sort of this special directory in your home directory. Now the special directory is important because we want to use that to sort of bootstrap the project. So I can go into my home directory, ~/ I should have a folder called FVM. Inside there, we will go to versions 3.22.0. Then there's a bin directory, which is where the binaries are. And inside that, we have Dart and Flutter, but we're going to use Flutter. So essentially, instead of using Flutter that's normally in our path, we're going to use this version of Flutter and just do a normal Flutter create. So we can go create, and we're going to call this Flut Tips. However, I realize I'm not really in a good spot to do this. I'm just in my home directory. So I'm actually just going to go into my project directory and we're going to run this right here. So FVM versions, specific version, bin, Flutter create, and I'm calling this Flut Tips. And now, if we actually open that up in VS Code, we'll see we have our normal, starter project, but it is, if we go to our pub spec, based on the version stuff, we have, this SDK, and everything's good. So that bootstrapped us. But the next thing we want to do is actually tell, essentially, this Flutter project, hey, what version of, Flutter do we want to be using? So for this, we just want to go FVM use, and then go 3.2.0. And we've already installed it, so it should be good. Now it's prompting us, do we want to add this to our git ignore? Yes, we do, because we don't actually want this folder that it made to be version controlled. That wouldn't, make sense. What will be version controlled, though, is this .fvmrc file, which is just something that's going to tell, when someone else clones this project, or maybe you, go to a new machine and need to clone it, we can, it will reference, and you have this sort of one as a reference here, and it will know how to work with that when you reinitialize it. So we have that now. And basically the way this works is, instead of running all of our things with either Flutter or Dart, we actually start by going FVM Flutter pub get as an example. And this will not just use this won't use our global Flutter. This will use whatever one is configured here. So it's actually using this, and you'll see the Flutter SDK. This is just a symlink to the specific folder, which you'll see is .fvm, or it's a symbolic link to that path that we saw when we bootstrapped the project. But now we know, we're going to be using 2.2 in this, or sorry, 3.22 in this. And of course, in other projects, we can have different versions of Flutter or be using the global one. Another thing we can do is go fvm Flutter Doctor, of course, just like we can do a Flutter Doctor. And we can just make sure everything makes sense here. So I'll just make this a little bit bigger, and we'll see we're on channel stable of 3.22, all this kind of good stuff, and everything is great. So there we go. Versus if I actually just do Flutter Doctor, at least in my environment, we're going to see that I'm on 3.19.5. So that's my global one right now. But in this project, we're using this. We just have to remember to have those aliases, and we're good. And that's for pub get, that's for clean, that's for really anything. And similarly, you can do the same with any Dart commands. Like if you're making a CLI, you can still use fvm for managing your Dart version. Okay, that was tip number 1. On to tip number 2. All right, before we get right into tip number 2, I sort of have this boilerplate set up right here that just will save us some time on creating files, but I've kind of broken up our tips into these different chapters here, and it'll just make it easy for us to work together. Now, I have all these imports here, right? So here comes tip number 2. I have, chapter 1, chapter 2, and I could, of course, go and, find chapter 1 by importing it. We'll see that gets imported there, and I can keep doing that, but I'm going to have a whole long list of things here. Something that's nice to do in this specific case, especially when something's like compartmentalized like this, is inside my chapters directory, I just have something called chapters.dart. Of course, you can call it whatever you want. And in here, we can actually export all these files like this. Then, instead of importing all these individually, I'm just going to do this, and you'll see it actually imported chapters, which was nice. Because I'm importing chapters and it's importing all these, everything here is already imported. So it kind of saves us a lot of stuff at the start of our file when we do it this way. So that is tip number 2, using export. So the syntax is just export and then the name of the file with the relative path. And since it's in the same folder, it's just a ./ and we're good to go. So tip number 2, done. Okay, tip number 3 is we're going to go to the analysis options here. And this is something I like to do at the start of a project because, for instance, maybe I'm in my main.dart, and maybe instead of this, or let's just show an example, I'm going to get rid of the const here, and I start to get this error here, or this warning. And this warning is a great warning. We should be seeing this because we can make this more efficient by having a const. But early in development on a project, a lot of the time you're kind of building, kind of like temporary UI that is going to eventually be dynamic. Like maybe you're just putting in, placeholder text and stuff, but it's going to come from an API, and it gets a little bit annoying to start seeing these things, or like you actually go along and fix them, but then you have to unfix it because you start to put dynamic things in. So at the start of a project, there's a few different analysis options I like to start with, and I'll put them in here. So we have prefer const constructors, and you'll see as soon as I actually have that, we get rid of that warning there. It's no longer saying, hey, like there's a warning. There's also prefer const constructors to create immutables, and that's similar to this one, but it's meant when you have like a list of things. So I like to have that one too. They kind of go hand in hand. I also don't mind the depend on reference packages. So this is something like I use a package called collection a lot for doing things like list manipulation and stuff. The collection package is something that Flutter requires anyways, and I don't want to have to like install it separately, and I can of course import it, but I start to get like a warning. So I don't mind having this to false because I don't really, I think it's fine. That's, your decision though. And then also avoid print, although I do agree we shouldn't use print in production. Again, when you're starting a project, it is, something you're probably going to do a lot. You're just going to want to print and maybe you don't even have a debugger logger, package set up or anything yet. So it is, something I like to do. But what's important is I do at least like 3 of these 4 when I'm actually like far along in the project or ready to ship something. I end up removing these, getting rid of them just like this. And then I can go into, my problems tab, and I'll have to save this first. We should see the problem here. So you'll see this, and then I actually will go through and fix these things that it's telling me to do. So there you go. Analysis options. prefer constant structures. I think that's the most annoying one to me, that is just nice to have, again, just at the start of a project. All right, tip number 4. This is a cool one. So let's just save all that stuff and let's go to chapter 4. So I already have this sort of set up. It's just a basic app, basic scaffold here. And we're going to work with lists. And I'm going to show 3 different ways we can essentially do a list and explain how it can get better each time. This is kind of almost a benchmark test in a sense, you'll see in a moment. All right, so here we're going to start by making a body. And this is going to be a list view. And within here, we're going to do this the worst way possible, the least efficient way. And for this, I need some sort of fake data. So I'm going to just actually make some data right here just by going final items equals a list, and it's going to be a list of type string, dot generate. And here we can actually just generate by putting in a number. And I'm just going to do 100 for now, but we're going to increase this in a little bit. And then we get the index back, and we want to just return item with that I. So this will basically be a list of strings where it's item 0, item 1, item 2, whatever. And yeah, the worst way you could do this if you're trying to make an efficient list that scrolls nicely is just to go children, and then we can take items and we can map them, and remember to convert it back to a list after. And inside here, we will actually do something where let's just call this item, and we're going to let's return a card with a child of a list tile, because I love list tiles. And the title will be a text of that item itself. So I'm going to save that. And let's actually open up our app. We haven't even seen this yet, actually. This is the basic app that I put together for this demo, just with each of our chapters here. So chapter 4, for instance, is what we're on right now. And if I open this, I get this list. There's 100 things. And if I try to scroll it, it's actually okay, but we only have 100. Now let's make this, something like 10,000, for instance. And we'll go again. And scrolling kind of with your mouse wheel and stuff isn't. Oh, you know what? It's because we need to actually do a rebuild here because this isn't part of our build function, so it didn't get the hot reload. So here, if I scroll with my scroll wheel, it's kind of smooth, but it definitely gets really janky, when I'm like doing this with the wheel. And that's especially true on web. You'll see, it gets pretty janky. And what if we had 100,000? Now that is something I'm going to do, except I've noticed doing 100,000 this way gets so janky that I actually think it might corrupt my recording, perhaps. So we won't actually test that one at 100,000. So that is, the worst way to do it. What I'm going to do, just so we can kind of like have this in the source code so people can kind of see the differences, is I'm going to wrap this in a builder like this. And we're actually going to create a enum here, just called approach. And we're going to have bad, which is the one we just did. We're going to have a good one, and we're going to have, a great option. And those are the 3 we're going to see. And in here, what I can essentially do is do a switch on a variable that we haven't made yet. Let's just make a variable called approach, and it's going to be equal to approach dot, we'll start with bad. And this could actually be a constant right here. So we'll just switch around approach, and we'll go case, and we'll just do approach dot bad, and that's where this code would go. This will just let us, toggle between them pretty easily. Now here, I'm getting this warning. I'm just going to go add the missing cases. And for now, we will just, so that this actually compiles, we'll just return a size box, and everything's good. Okay, so we have it set to bad. Everything is just what we saw before. So let's do the better approach. So I'm going to, or the good approach, I guess. We're going to return a list view again. And here we're going to use a list view.builder, which, I imagine you're familiar with. And this just does a lot more efficient things for dealing with when things are out of memory or out of view. They're not actually like fully in memory yet. They're not being painted, all that kind of stuff. And here we need context, and we need an index. And we also have to remember to, of course, have an item count. Otherwise, this will just keep going forever and we'll run into an issue. So we want to use items.length here for the count. And here I'm essentially going to grab the same thing. We want to keep this benchmark kind of the same. And we just have to cast item to a variable. So we'll just go items at that exact index. So this one, and we'll change to good here. This one's going to be a bit more efficient because it's actually using a builder. It's going to be a little bit smoother. Let me just make sure that it is using that one. Okay, we are right here. So a little bit smoother, a little bit better, even though I've changed this to 10,000 now. But you can see it's still kind of janky. And you know, you might have to test this yourself to really feel, because you don't know how I'm moving my hand, but it feels a little bit janky. Let's do one more option here. So for great, and this one's a cool option, we'll do it exactly the same, except we're going to create what's called a prototype item. And the prototype item allows Flutter to basically figure out how much space something's going to take up, so that it can kind of pre-render these things in the right spot and not actually have to build them, you know, properly. And what we want to do is actually just really use this same widget here. So I'm just going to copy and paste it. And in here, we're just going to use items.first. So we'll just take the first one as kind of the prototype. And we have an extra guy there, and let's save that, and let's change this to great. And I'll just do a full rebuild, and we'll go back to our item 4. And now I'm going to try and do it, and you'll see it's like buttery smooth. It's really nice. And that's because it kind of can calculate, it knows how tall these things are going to be, and it can kind of position them as it should. So some, you know, interesting stuff happening under the hood there. And even if I change this to something like 100,000, we're going to see, and again, I forgot to rebuild. I should just have this in the build function, because then we would actually get the hot reload for that. But let's go here, and we're at 100,000 now, and you know, I'm still getting that buttery smooth. And if I was to set this back to good, it would be really, really laggy. And if you put this on bad, like, I think my computer would probably crash, to be honest. So we're not going to do that. Feel free to do it on your own. So yeah, prototype. Now this only works if, you know, your children are all going to be the same, essentially, size, at least the same height, because you'll run into, you know, problems. It won't be able to calculate if they end up being a dynamic. So keep that in mind. Another thing you can do as an alternative, if you happen to just know the height, you can do item extent. And this is virtually the same thing. The only difference is you have to know what the height will be ahead of time. And using a prototype item, to me, makes more sense, because you know, I would have to kind of like measure it with a ruler or do some debugging to find out. But if we said this was 100, it would essentially work the right way if this number was correct. But I prefer the prototype item approach for the reasons mentioned. Number 5, chapter 5, tip number 5. Okay, so let's just close this stuff, and we'll open up number 5 here, which again, just a nice empty thing, just trying to save time, people watching me trying to type this out and rename this stuff. Okay, so let's talk about responsive. So of course, you know, there's many ways to do responsive things, there's packages and stuff like that, but I want to show you the way that I really think just works great and is super simple. So what I'm going to do is, first of all, we're going to create a utility. Now, normally I would put this in, obviously, its own file, but for the sake of this tutorial, you know, we're just going to do it right here. But we're going to create, essentially, a couple things here. We're going to create an enum called screen size. And screen size, you know, we're going to be dealing with small, medium, and large. Small meaning kind of like mobile, medium meaning, you know, an average screen, large being like, you know, a big monitor, essentially. And you can, of course, have as many as you want and rework this the way you want, name them whatever you want. And I'm just going to create a class called screen utils. And we'll put some consts in here. So I'm going to have a const for a breakpoint of small. So basically, breakpoint small, we're going to make it like 576. And I'm going to put 0.0 because I want this to be a double and not an integer. So we'll just do it like that. And we'll also have one for breakpoint medium, and I'm going to make that, you know, 992. These are just numbers I think that are popular in like web development for breakpoint sizes. So what this means is anything that is smaller than this number will be considered small screen. Anything that's, you know, bigger or equal to this but smaller than this will be medium. And we don't need a breakpoint for the next one because basically if it doesn't fall into any of those, we'll assume it's large. So those are kind of our breakpoints. And what we're going to do is I'm going to just make a static function here. So we'll just do, and it's going to return a screen size here. So it's going to return one of these enums, and we'll just call it size. And we're going to expect that the build context is going to be passed in because we need context to do anything with media queries. And what we can do is we can make something called width. So I'm going to just go width, and it's going to be just really equal to media query dot of context dot size dot width. So that just gets us our lovely width that we can do something with. And what we can do is if the width is less than breakpoint small, then we simply just return screen size dot small. Otherwise, you know, if the width is less than, I think I said greater than, I meant less than, obviously, breakpoints medium, we return screen size medium. Otherwise, we return screen size large. And of course, you can name these whatever you want. You can change these breakpoints. You could have more breakpoints. You could have a bunch. You could even do something for like tablets and stuff by like checking the orientation. There's a whole lot more you could do here, but this is just a very basic example. So this would be ideally you'd put this in its own file called like screenutils.dart. Let's call it that. We're going to keep it here. Another thing, and this would be also in a file, is we're going to create a stateless widget, and we're going to call this just base component. You could call it base widget, you can call it really whatever you want. And the idea is this will be like our normal component that we're going to use throughout our app, and you'll see why in a minute. Essentially what we're going to do is in our build function, we are going to override this to essentially get that screen size first. So we'll just do final and we'll just do size, and we're going to use our screen utils and we go dot size, and of course pass in the context, and that's just simply because we are going to need context to do all this stuff here. So we get size here, and this is going to be a screen size, right? This enum here. So now we can do a switch statement on size and actually do things like case screen size dot large, do something, and let me just put a break right there, and let's just get these other ones in. Just a nice little thing we can do. Bonus tip, you can just get these like this. I wish it would do all of them, but it doesn't. Now the order of these matter. Well, I guess it actually doesn't matter, but I like keeping things in a logical order. We go from large to medium to small. So what are we going to do here? Well, what I want to do is inside our base component is we're going to create three kind of like build functions, but they'll be a little bit different. So we're going to have something called widget, and we're just going to call this body, and it's going to be just like our build context. Okay, and in here, by default, this component is just going to return we'll just do a const of a size box dot shrink. Just very optimal, empty thing to return. And I'm also going to do some other things here. So we're going to have one called body MD and body LG. Okay. All right. So we have these sort of things here, and then basically based on the screen size in our build function, we're going to call these dynamically. So I have these things here. So if it's large, we're just going to return, of course, body large, and we do have to pass through our context, of course, and we can get rid of that break. And we'll just do the same with these, and this will be body medium, and this will be body small, or just body. We just have body as a normal one. Now, let me just get everything looking good here. Now, what I also want to do is I don't want, when I'm working with this, to have to supply all of these. I want body to be something that always gets supplied, and then we can basically go through and override these on a case-by-case basis for the components that need to change. So body.medium won't return a size box.shrink. By default, it's actually going to return just body. And that's similar with here. Our large will just by default return the body. If this doesn't make sense yet, it very much will very soon. Okay, so we have these cool things here. Now, for our chapter 5 stateless widget, what we're going to do is we're actually going to create, this little demo component. Let's call this chapter 5 body. Let me just do that again. We just want a stateless widget, chapter 5 body. And in here, instead of extending stateless component, we're going to extend base component so that we get access to all those things. And now we don't actually ever want to be touching our build here. We could, and it would just work as it normally would. But what I want to actually be doing is overriding body. And in here, let's return something like a container with a width of double dot infinity and a height of double dot infinity and a color of, let's just do colors.red. Okay. Now we want to make sure that we're using this, so let's uncomment this again and do chapter 5 body. So let's just see how this works in its most basic form. So I will go back here and we will go to responsive, and we'll see we just have a red box as you kind of expect. This is basically just returning this. And basically what's happening here, right, is it's using base component. Base component has a build method. It's detecting the size, and regardless of which size my screen is, I'm going to always get this red because no matter which one it is, this will go and use body by default. So as long as I have body, I'm good. But here's what I can do. That's kind of fun. I can basically copy and paste this and do body medium. And basically I'm just overriding this, right? Body medium. So it's no longer going to do this. It's going to do what I say in the component. And let's do this for body large. And let's just change these colors. Let's make blue and make green. Now this is just a demo, you know, the color, this wouldn't be something you'd probably do. You'd probably do something like shifting the layout of something and so on and so forth. But now what we actually have is when we get to the different sizes, we actually see they change. So yeah, that's pretty cool. It's just a nice way to sort of have a component, just this base component. I have this on pretty much all my projects in some way, shape, or form, with some other things too. But yeah, this is cool, and yeah, it just allows me to do things. And of course, I can decide, you know what, I don't actually care about overriding medium. I want to go right to large. And if we do that, we're going to be red all the way until it actually gets to that huge screen, which I guess is that, and we get the, you know, that one there. So yeah, that's kind of what I had in store for this tip. I think it's pretty cool. And again, you know, this example source code is linked below. Number 6. If you've watched any of my videos before, you've probably already seen this one. I use it all the time. It's called a makefile, and this is not actually a Flutter specific thing, but I like makefiles because they're not Flutter specific. For instance, in Node or in anything that uses npm, you can do something similar in a package.json file, create basically your own custom commands, but that only works for that language. Makefiles are, you know, are just really like a simple way to kind of create like a shell script without actually like writing a whole script. And simply with here, for instance, I can make an alias. So I can do something like PG, and this is what I want to do my pub get. And because I'm using FVM here, I can just go FVM, Flutter, pub, get, and put this in here. So it's makefile, capital M, no extension, and then the name of the alias that I want to do. And now in my root directory, or basically the directory where I have the makefile, I can run the word make and then just do PG. And this will actually run FVM Flutter pub get. We could have some other ones too, which I'll just copy and paste in rather than typing them out. Maybe we have one for building web. Here we go, FVM Flutter build. And look, WASM, cool, we can do that because we're in version 3.22 now. You know, something for cleaning, something for deploying, et cetera, et cetera. So this is super helpful, I think, for 2 reasons. One, you know, you don't have to type these things out all the time. You can just remember these. But even if you forget these, this is like kind of like documentation for you, right? You can come back here and be like, oh, how do I do that again? And you know, if you don't even want to use the makefile, you can then just go and copy and paste it and put it in. But you know, I think this is cool. This will work on this will work on Mac and Linux right out of the box. Anything Unix has make, as far as I'm aware. Windows makefiles work. You just have to install something for it. Just Google, you know, makefile Windows, and you'll find the instructions for that. But if you're using the Linux subsystem on Windows, which you absolutely should be if you're a developer on Windows, you should have make already. So just make away. Tip number 7. This is something I think super helpful, especially now that Flutter Web is really maturing with the WASM. And this is something that I have had to do on quite a few projects because I do have some cross-platform apps in production that are native apps, but they're also deploy as web. You know, I think that Flutter Web is friggin' awesome. I know everyone complains about it, but I think people are using it incorrectly and for the wrong things, or not doing things very properly, and they're saying it's slow. I think with WASM now, although it's only supported in certain browsers, you know, it's even better, and it's just getting better. Now, something that people run into, and I think why they complain about web, is there's a lot of packages maybe that aren't supported for web, and that could be because, you know, the package author's lazy or whatever, or because it's not even something that would ever work on an operating system. And I'll do an example here of what, you know, of something like that. So one problem though in working with some of this stuff is we need to create sort of like a native version of an implementation and a web version, and for 2 reasons. One, you know, we don't want to always have to be checking, is web, do it this way, is that, like, we just want like a nice API that we can make. And secondly, sometimes when you have like certain JavaScript code essentially, and inside your code base, your native app won't even compile. It'll be like, I don't know what this is. Let's start HTML. Da, da, da. Now that might have changed since we're now, you know, since WASM, there's now the new recommendation to use the web package. But I still want to show this because even if you can still build properly, this is still like a cool approach. So what I'm going to do is we're going to go in here and I'm going to make a new folder, and we're just going to call it device utils. And I'm going to make something first called device utils interface. And this is essentially the interface, meaning like the explanation, the header file kind of what these utils will be able to do. So here we're going to create a abstract class called device utils interface, because it's not actually it's not actually a class that we're going to use. So it's abstract. And we're just going to make one example here. We're just going to call it like update date time, and you'll see why it's called that when we actually get this working. Now you would create other things in here. Maybe you want to be able to like share something to social, which, you know, works different in web potentially than whatever. You know, there's various things you could do, but just think this is like one potential thing we want to do. We want to update the date time. So I'm making this here. Now, the next thing we're going to do is we're going to create 2 new files. We're going to create one called device utils web.dart and device utils native.dart. So in our web one, this is where we would like kind of safely write our web specific code with potentially with JavaScript and everything like that. So what we want to do is we'll make something called class device utils. Now I'm not calling this web, I actually need to call it implementation. Or I could call it anything, but this essentially has to be the same name as this one here, because we're going to do something kind of like a cool little trick to dynamically import this file. So they have to be the same name. And what we're going to do is we're going to extend the device utils interface right here. And we are getting this warning here, so let's do that, and let's create that override. Now, what I want to do in this is we're actually going to import the package web. So I know I said we're not installing any packages. There's one I want to install just for this demo, just so we can actually do this properly in the new way, because I don't want to really be showing like the old way of doing stuff using like Dart HTML and like JS context. So I will be going, I need to go fem flutter pub add web. So this is just the recommended package now to do JavaScript interop. And what we're going to do in here is we're actually just going to kind of do some JavaScript code, which is kind of nice. It's still Dart, but it's essentially like interfacing with JavaScript. And we can just make something called div, and it's going to be equal to document, which comes from the web package, dot query selector, which is very much like JavaScript. And we're going to get something called date. And so basically there's going to be a div somewhere in our web page called date. And then what we can do is we can go like div.text equals, and here we can just go and we can just say like text set as, and let's use the datetime.now. We should also be doing a null check on this. Div could be null. So let's just go if div does not equal null, do this. Now, what we need to do for this is I'm actually going to open up our, in the web folder, the index.html, and we're actually going to just create a little tag here. And again, this is for demo purposes, but you know, if you had like a Flutter app embedded in like a larger website, or you wanted to manipulate something to do with the website and not the actual canvas of Flutter, this is what we'd have to do. So we're just going to call it class. It's going to be called date. And I am just going to make sure that this becomes visible for us. I'm going to add a bit of CSS just inline, super, you know, bootstrappy, whatever. But we're just going to say it's position fixed, so it's like kind of doesn't scroll with our site. We're giving a top and a bottom. We're giving a big font size and z-index of 1,000, so it gets on top of our app. So we're just going to have that prepared for later. So basically, we're going to talk to this. We're going to say, hey, .date, you know, do something with it. And what we're doing is we are setting this. Now, let's open up native. And I'm going to essentially copy the same code here. But we don't want to import web here. In native app, we're not going to be able to access this at all. So we might do something different. Maybe we just like, you know, do a, you know, show an alert or something. I am just going to do, you know, print, and we'll just do, you know, datetime.now, just as an example if we ever, you know, wanted to run this. But basically like, hey, I want to handle it this way on native, and oh, I want to handle it this way on web. So how do we stitch all this together? Well, the last piece of the puzzle is we want to make something called device utils .dart. And this is kind of the magic file. This is the one we're actually going to be importing when we use it. And we're just going to make something called device utils, and it's going to extend device utils implementation. Okay, and it doesn't have to do anything. We're just extending it. Now you see this automatically imported native, which is not exactly what we want, because now on the web version, it would be just using the native one. So there's this cool thing we can do. We can actually go import, and we can just go device utils web, web.dart, because like that. If this is like a conditional import, essentially, we go dart.library.io. So what this is saying is we're going to import this, but if it's dart.library.io, meaning we're using native IO, we are going to import this one instead. All right, so let's go back to our actual chapter 6 now, which I don't even have open, and let's actually interface with this. So I'm going to make just a floating action button, and just for example purposes, and let's give it a child of icon, and we'll use like icons.alarm because it's something to do with time. Cool. And we need an onPressed event. And here, what we can do is we can go device utils. You'll see we want to make sure it's importing device utils and not anything else, which it would be. This is the only place we have the word device utils. And because device utils is essentially implementing this, which is implementing this, we have the IntelliSense of this. We can go device utils.update datetime. And because that magic import is happening, it'll know, hey, if it's web, do it this way. If it's native, do it this way. And then we have a nice little setup. So I'm going to build this for web just to see if this actually works. So for building to web, I'm not going to build to web. We're going to run to web. So I'm just going to change this to web here, change to Chrome, and we'll get that. I'm going to stop the Mac app right now and actually just get this building. As we are on chapter number 7, not chapter 6, so we're just going to put this in the correct spot. Chapter 7, boom, and make sure device utils gets imported again. All right, let's go to our Chrome app now. So this is obviously running web, and if we go to our chapter 7 and press this floating action button that we made, we'll actually see, oh, this text is getting set. And this is not within our Flutter canvas, right? This, if we actually inspect element, is completely outside of the Flutter context. We just happen to be communicating to the browser to do this. So we actually have this div called date. That's the one we made in the index.html. So yeah, just a kind of a dumb example. Like obviously, like you probably won't have a need to do this. Probably better just to do that in JavaScript, but there's definitely tons of times that you want to work with a JavaScript API, and you obviously need your native app to kind of handle it a different way. So that's that tip. That's tip number 7. Going on to number 8. So number 8 is just an extension that I like that maybe it's under the radar. I just, maybe everyone knows about it. I don't know, but it's not, an official extension or anything like that. But it's called Dart Import right here by Luan. And having this installed is kind of nice because what you can do is you just run, Dart. Let me just find import. Sorry, let me remember how to run it. Fix all imports. And what this will do is it will go through your whole project and fix your imports. And what fix means is, it's going to order them in the right thing. It's going to make them all relative URLs instead of absolute, or paths rather, and so on and so forth. So I'm going to run it, and you'll see fix all imports. You see it's going to open up all my files and actually do, all these things. This one wasn't saved ahead of time, so it kind of got mad at me there, but let's just save everything. The example I'm showing right now, obviously we don't have a lot going on. It's a pretty simple project, but on a bigger project, we have a lot of imports, and you have imports that aren't being used anymore. This will go and fix it. So I'm shouting out that extension because it's super helpful. And, if you're, have a boss or something that's like, how much lines of code did you change today? Running that, is going to make a big difference in your pull request. Okay. All right, that's about it. There's one other tip I want to do is, kind of some refactoring tips that I've, picked up along the way because I'm lazy, want to find ways to do things. So we're going to chapter 9 here, and some of these, you're probably aware of. Obviously, maybe not obviously, but we have obviously Control-Shift-R on a Mac at least, and it's probably the same on Windows. We have these sort of, built-in ones, assuming you have the Flutter extension, which you obviously, you should have. If you don't have the Flutter extension, start with that. But we can, wrap things in center and columns, and those are all super helpful. One thing that I find myself wrapping often enough is a stack, and that's not in here. And I don't want to edit this extension or make my own just to have a stack. But fun tip, just wrap it in a column and change it to a stack. It's the same shape, so it works pretty easily. That can also be true for something like a future builder. I have builder here and stream builder, but I don't have future builder. But say I want to do a future builder, I'll wrap it in a builder because you get all this lovely stuff that's kind of annoying to write. And then we just change it to future builder. And then we, of course, need a future here. So tip number 3, I'm like, I know I need a future here, and I'm going to call it get data like this. And rather than now going and making that and typing it out, I can go command dot on a Mac, command dot, and it gives you some options here. Create method, in this case, call get data, and this will be a method. And in here, I still have to like decide what this is. We're going to do a future of maybe a string. It's going to be asynchronous, and we want to essentially return a string that says hello, but let's make sure we are, awaiting a future dot delayed for, duration of 5 seconds. Just something like that. And we do have to remember, obviously, in a future builder, there's a second parameter called snapshot. And here we can do the normal future builder stuff, and everything is good. But that's not what this is about. So I just want to show, simple ways to kind of hack the refactoring tools when there's not something there that you want. So that's basically it for this video. 9 cool tips. Check out the link in the description. Please subscribe if you found this good. And, if you have any other tips that you want me to cover, or, modifications of what I'm doing that could be better, which this happens pretty often in the comments, let me know there. Let me know in the comments. And thanks again for watching, and we'll see you in the next one.